Okay, let's look at another example. We want to find the magnitude of the vector. That basically just means how big it is, right? How long it is. So they give us component form. This means in the x direction, that's our I horizontal component, and in the y direction, so our vertical component. So I like to just sketch it. In fact, let me just do a quick rough sketch here. So here's our coordinate plane, -5, so that'd be this way, right? So it would be something like that, -5, and then 12 up. So it'd be somewhere up here. So if we put those together, so there's -5, here's a 12, let's say. So the actual vector, if we start it here, is this guy right here. So I'm just showing the components they gave us. But notice that's just a right triangle, and it has side here, -5, side here 12. What's the magnitude? Hey, it's just Pythagorean theorem. You're just finding the hypotenuse of a right triangle. So of course, it's always going to be positive, by the way. You can't have a negative magnitude. So that negative just tells us it went left, but it's just 5 squared plus 12 squared. Of course, it's going to equal my magnitude. And so that is 25 plus 144, so we get 169. And of course, if we square root that, we'll get 13. And so the magnitude, we represent magnitude like this, kind of like a double absolute value. And again, I'm doing this arrow above it just to show it's a vector, because you can see this maybe is bold, but I can't draw bold, so I like to do the arrows above it. So the magnitude equals 13. And again, I don't like to try to remember more formulas, things that we need. It's just Pythagorean theorem. So a lot of what we're going to see as we work with vectors are just applications of things we've already been doing.